10.17. Answer the following questions. A. In a single slit diffraction experiment, the width of the slit is made double the original width. How does this affect the size and intensity of the central diffraction bend? So when you increase the width of the slit, right, then the size of the central maximum that decreases. So if you make the width of the slit double, then the width of the central maximum that reduced to half. B. In what way is diffraction from each slit related to the diffraction pattern in a double slit experiment? So intensity of interference fringes in double slit experiment, that is modulated by diffraction pattern of each slit. આ ટાઈપનો એક એક્ઝામ્પલ પણ આપણે જોયો કે સેન્ટ્રલ મેક્સિમા formed by the diffraction pattern and in that the interference pattern is accommodated. એટલે જે independent diffraction નું superposition આપણે લઈએ તો interference pattern લઈ લેવાય. C. When a tiny circular obstacle is placed in the path of light from the distant source, a bright spot is seen at the center of the shadow of the obstacle. Explain why. So that is due to diffraction from the edge of the obstacle. It implies that from that opening. So due to the diffraction of the light, okay, central, that will be the bright spot, which one will be surrounded by some faded part. Then D. Two students are separated by a 7-meter partition wall in a room 10-meter high. If both light and sound waves can bend around obstacles, how is it that the students are unable to see each other over even though they can converse easily? Now see here, the diffraction depends on the factor lambda by A. So here for sound waves, lambda is large one. So lambda by A, this factor A, that is the opening of the obstacle, that is large one. Clear? So if this factor lambda by A is large one, diffraction will be more, so one can hear the sound. But if we think about the wavelength of visible range, suppose we take the average, that is 6 into 10 raised to minus 7 meter, then lambda by A, this factor will be very small for the visible light, and therefore one can't see the person standing behind the wall. E. Ray optics is based on the assumption that light travels in a straight line. Diffraction effects disprove this assumption. Yet the ray optics assumption is so commonly used in understanding location and several other properties of images in optical instrument. What is the justification? Again, we can say the diffraction depends on lambda by A. If lambda by A, that is very small, it implies that the diffraction is negligible one. So in that particular case, we can consider the ray optics. Clear?
पोलराइजिंग में हमें पता चला